Hey everyone, today's talk is about temporal and the dates time is about to end. My name is Douglas. I'm developing for the web with TypeScript Reaction Rails for a bit more than 4 years now, and I'm currently working at CodeMiner 42. What you see here today, you will see why JS date objects are problematic, the workarounds people needed to resort to, and how temporal is coming to help us with their new core concepts introduced. The requirements to follow this talk is you will need to be familiar with the unique epoch time representation, which is those seconds counting since the beginning of 1970s. You will need to be familiar with how time zones work. You will need to have dealt a bit with JS date constructor and have in mind the various ways we think about time, such as dates, days, hours, seconds, weeks, months, years, and a bit more abstract ways like tomorrow, the end of the day, or in a couple of weeks. You will need to have the concept of durations as well, such as it takes 3 minutes to accomplish something, or once I remove this wire, I'll have 15 seconds until it explodes. So let's start talking about JavaScript date flaws. Uh, dates back to 1995 when it was copied from Java, which by its time in 1997 threw away and fully replaced the date library. And JavaScript still uses this date util after 30 years. And if you already have dealt a bit with the date object, you will know that it's not that trivial to manipulate time, since operations like the one I'm going to show you now are pretty usual when we want to set a date object to the future. So what I did here was to set two date objects, one to act as a reference and another one to represent a point in time somewhere next week. And to accomplish that, I need to use the setter method and for the next week object, and use the getter method to the first reference object and add a 7 to it so I can represent a time 7 days from now. Notice that the set date returns, first it mutates the first object. So it's the same reference object, but with a different state now. And the set date method will return milliseconds. It won't return a nil date object, or neither can be chainable by returning the same date object. Another way we usually deal with time in JavaScript is to calculate how many milliseconds a time representation is the value of some representation. For instance, I took the 24 hours in milliseconds representation, and I want to create a date object date to 24 hours from now. How do I do that? I grab the date.now method that will return milliseconds and add the milliseconds that I calculated before. That will give me a date object date from 24 hours after the first example that I show you. So another fun thing is that months start at 0 for some reason. I don't know anyone that counts January as 0, but JavaScript does. And also, for instance, if you try to get the month that the number that represents April, you will get the number 3. You probably have fallen the need to add 1 to represent the number of the month. So that's some workarounds that makes JavaScript date library not very straightforward to work with. And also very few constructs come out of date. So all those three methods, the now, UTC, or parse, they will output milliseconds since Unix epoch. The constructor of the date class will return a date object that can be by its time converted or generate an ISO string, an UTC string, or make a time string based on our runtime locale. So it's either UTC reference, or is it milliseconds reference, or a local time representation. There is no native support for handling time zones. the only time zones it will work with, it will be either the local system time or the universal, the UTC time. To handle time zones, you will probably need to recur to the Intel global object, but that makes another layer of complexity. So you might better go through to a util that wraps them up, since data itself does not convert between time zones. It also does not support calendars other than the Gregorian, such as the Chinese or Islamic calendar, and it will assume your time zone when building the object. So that's the part that I think it's a bit dangerous, that can lead to wrong assumptions of time, since if your server runs in a time zone different than yours in local, you will generate different date objects. That might get out of hand real quick. So that all that said, our best bet will be to go to an external library that will wrap those flaws to us for us. For instance, in the past we had the Moment.js that is considered completed software. It's pretty good still, but it's just considered completed or legacy. By its successor, we have Luxon, which is pretty good as well. And the date functions library is another very famous and good alternative. They all carry their own capabilities and characteristics. But for instance, I took the Luxon one as an example on what we want when we want to have a functional or ergonomic library to handle time. First thing we notice is that the transformation methods are chainable. So, for instance, having the datetime class calling the now method will have a new datetime object with the same set of capabilities, indicating that the object is immutable. So every transformation returns a new object. For this example, you can find at the very first page of the documentation for Luxon, and you notice that it already have the support for time zones and to adding or subtracting time from a date object. And finally, we can convert the object we molded to a ISO string, for instance, if we want to use it that way. So where Temporal comes to help us then? Temporal will be a global object such as date and Intel. And Mozilla recently, by the end of January, released it hundreds of pages of documentations for it. And you can check that in the MDN docs. I really recommend you to check that out. And Node.js just started a discussion about enabling it. It was earlier this week that the discussion started. You can check that out as well. And it's currently in stage 3 of development. So it can be tested in your browser or through the polyfill. You can access the TC39 website and check the docs. You can test that in your console. If you open the browser console, it's available there. And it's for sure going to be the most comprehensive one, or at least one of the most comprehensive native APIs to handle dates. So the general availability is just a matter of time now. The core concepts it brought to us. The first concept that I want to talk about is the exact time, which represents a precise point in time. For instance, when an event happens, or a document was created, or something was persisted, or when the a call for proposals closes, for instance, it should be a precise point in time. And it's represented by those two constructs, the instant and zone datetime. The other concept that was brought to us is the wall clock time. It represents hours and days, but not necessarily attached to any time zone. It just represents a unit in a given calendar. For instance, December 21st of 2012 or 2 minutes to midnight. Those two are wall clock times. Another third concept they brought to us is the duration. that represents length of time. In other words, it can measure time or measure the difference between 2 points in time. That's the duration or a period. For the exact time, the first construct that we have is the instant. The instant, as we already said, represents the exact time of an event. Has nanoseconds of precision instead of the date's milliseconds, and does not assume any calendar or time zone in favor of being just UTC. It's universal. And how do we build an instant? First, we using the temporal module, we use the constructor for the instant class using the new keyword and pass the number of nanoseconds, that's important, to the constructor. Notice that the 0n here represents a big integer. So it's not just an integer. Another way to build an instant is to call the instant method of the now class. That will work pretty much similar as the date.now, but instead of returning milliseconds, it will return the instant object to represent that instant in time, that exact point in time. If we need to get the milliseconds or the nanoseconds later on, we can, but it will always return the construct that represents an exact time. The other construct that represents the exact time is the zone date time. It represents still a exact time, but for a time zone and a calendar. And to build that, we have the same, from inside the same module, we have the constructor for the zone date time class. And to build that, I've grabbed the now nanoseconds with the class we've seen before, grabbing the epoch nanoseconds property of it and passing it to the constructor as a big integer. But notice that by calling a zone date time, we cannot just say how many nanoseconds passed since Unix epoch. We need to explicitly say which is the zone that we want to have the zone date time for. For my case, I've used the utility method to grab my local time zone, which is in this moment American São Paulo. Passing those two to the constructor, you have the zone date time object that represents a exact point in time, but for a precise, for a certain time zone. The second concept that wraps some constructs is the wall clock time that represents a calendar, but it's subject to governed measures, such as daylight saving time and political time zone changes, for instance. And how do we build one? We use the class temporal.plainDateTime and pass the year, months, and day. And you will have the object that represents a point in a calendar. In a certain calendar, it assumes a default calendar, or you can pass another calendar to it. But it assumes to be the ISO calendar by default. It does not assume any time zones, though. The third concept that I want to talk about is the duration. Duration will represent periods of time in the ISO 8601 format, and it's pretty straightforward to understand. For instance, if I want to say during 7 days, I have the P7D code that could be read as P periods of 7 days or 8-hour shift, period of time of 7 hours, we can read that way. And how do we build a duration? We use the duration constructors that we pass an object to it, representing the subunities of time we want to apply a duration for. So for those two cases are the objects of the duration objects that represents the examples above. And what we can do with all that then? Each construct we use, we can use them to represent time. We can operate them to measure time. We can operate between the constructs, and we can be precise when converting dates and between time zones and calendars. That's the main goal. The interoperability between the constructs is the key feature of whole temporal thing. For instance, I want to calculate when the work starts and when the work ends. This example is sort of derived from the first one that I show you, but assume this one as I want to calculate based on when my work starts, 8 hours from then, when will my work end? I will need to create two date objects, and I will need to do that thing about to set and get the hours, and at 8 what? Just 8 to set the hours, and I have a mutated work end object that will be 8 hours from the work start object. With temporal, we can do it more. We can better represent the concepts of time we want to work with. For instance, I have the work start object that is generated from a certain date and a certain hour, a precise hour. And I can represent the 8-hour shift that I can create it by saying I know that the 8-hour shift have a duration of 8 hours, so I create from it, and I have a construct that represents the shift itself. And by adding the duration to the first work start exact time representation, I will have an exact time representation for when the work ends. So that's pretty powerful. No more adding 8 or magical numbers of some sort. So the takeaways I want you to have from this talk is that we have several words to describe time, and those words will be better represented by those new constructs. And Temporal API will give us a new set of tools, those constructs, to model time. The key word here is model time. Each of those constructs have a new set of capabilities, and we will probably not need much more of external libraries to do some basic operations in time, or even some more advanced ones. So the temporal is a long-awaited feature to save us time. Those are the references that I used to write this. They're probably going to be at the description of this video. And I thank you for your patience, and see you next time.